Okay, so last section we're going to look at for this week is 6.4. And we've already looked at sine and cosine in a lot of detail, all the transformations. Now we're going to look at the other trig functions. Tangent, cotangent, secant, cosecant. So for the first one, and this is the only one I'm going to go through all the detail, for tangent, there's a way we can write tangent using sine and cosine. Does anybody remember how to write tangent as a fraction? Yeah, tangent is sine divided by cosine. Well, if we know what sine looks like and we know what cosine looks like, we can use those two ideas to figure out what tangent would look like. But without going through all the detail, I want to focus on the bottom. So we have a fraction there. What are you not allowed to do in a fraction? Yep.
Use 0.
Yeah, you can't divide by 0. So now, if I draw the picture of cosine, does cosine ever cross the x-axis? Yeah, it does. So if it crosses the x-axis, then that means cosine does equal 0. Here and here. So that's 0. Anybody remember what's the first one again? Pi over 2. That would be pi. What's this one?
3 pi over 2.
3 pi over 2. So we have a problem at those two values. If you try to graph tangent, when you get to pi over 2, the calculation would involve dividing by 0. You can't do that. When you get to 3 pi over 2, the calculation would also involve dividing by 0. Does anybody remember what happens when you try to divide by 0, what the picture looks like? Yep.
Whole.
So you can get a hole. Sometimes that happens, yep. What else can happen besides a hole in the graph? Something that it gets close to but never reaches. Yep.
Break or wait, no.
A break, yeah. What's the third thing? Nina?
Asymptote?
An asymptote. And that's what's going to happen here. We're going to have asymptotes. Now, if you're wondering, well, how often do you have asymptotes? How often does the graph of cosine cross the x-axis if you continue it forever? Forever. So it's just going to keep crossing. It's going to keep crossing the x-axis. But we know where. We can predict it. It occurs regularly. It's not like it occurs randomly. That's 90. That's 270. So basically, you get an asymptote at every other multiple of 90. So 90, yes. 180, no. 270, yes. 360, no. Okay. So every other multiple of 90, we get an asymptote. So let's look at how we could sketch that. So let's draw 2 asymptotes in. Okay, I know I could draw a bunch of them as it goes on forever. Let's just draw 2. Maybe I'll put 3. I'm going to do one at pi over 2 and 3 pi over 2. All right, so asymptote at pi over 2, 3 pi over 2. If you want to put another one in, just, you could put one every other multiple of 90. There's another one there too. In between the asymptotes, I'm going to draw something. Okay. What I draw between the two asymptotes is going to look the same between every 2 asymptotes, but I'm only going to draw it once. Okay. So now let's pick a few points that are in between pi over 2 and 3 pi over 2 and make a sketch. First thing is I got to put tangent in, and I'm going to use the table on the calculator. And if we put pi over 2, watch what happens. It says error. Why? Because pi over 2 is an asymptote. Let's put a value very, very close to that. Okay, 1.57. I'm going to go just a little bit past 1.57. So what would be a good number that's just past it? Yeah. Yeah, 1.58. Something really close. At 1.58, I'm down at negative 108. So, way down. Okay, let's check right in the middle. What number is right in the middle of pi over 2 and 3 pi over 2? Pi. Let's check that one. So pi, we're going to cross the axis. And again, you can't put this in. 3 pi over 2 is an error because that's an asymptote. But what's a number that's just a little smaller than 3 pi over 2? A little smaller than 4.71. 4.7. At 4.7, I'm way up at 80, okay, on my graph. Way up here. So we need to connect those 3 dots. And the way they're going to connect is something like this. Stay very close to the asymptote. Start to go away from it. And then get closer and closer to the other asymptote. That's what the graph of tangent looks like. And it's just that repeated in every section. So if you wanted to draw the next section, just make a copy of it. And put it right there. That's another section. Just like when we sketch sine and cosine, we only sketch one section. I normally would only sketch one section, okay, but I'm showing you 2. If you want to see it on the calculator, there's tangent. What's happening on the left is I'm cutting off part of a section, but you can see the curves that you get. It goes right, the middle section on the screen, it goes right through the origin, and that's exactly what mine does. So that's what the graph of tangent looks like. Any question on that? Okay, so the other ones we're not going to go into as much depth. I just kind of wanted to show you why there's vertical asymptotes in tangent, and it's because you're dividing by 0. So, cotangent looks, that's tangent. Cotangent looks similar, but remember the difference between tangent and cotangent. You flip it. So cotangent is flipped. So what that does is you still get these curved sections, but they curve the other way. Okay, so what I'll do is I'll graph tangent and cotangent on the same screen so you can see them. Remember, I don't have a button for cotangent, so the only way I can type it in on the calculator is to flip it. I have to flip it myself. So what you're seeing in red, that's the cotangent. It crosses the axis at all the places the tangent didn't. Right exactly in between. Okay, so the ones in red that are curving down to the right, that's your cotangent. The ones in blue that go up and to the right, that's the tangent. So, a lot of similarities. You still get the same basic curve. You still have asymptotes. But look where these asymptotes are. 0, pi, 2 pi. Let's go back and look at tangent. I don't have asymptotes at 0, pi, and 2 pi. It's like all the asymptotes have shifted. They've all shifted one grid spot to the right. Okay, so when we had tangent, I said to you the asymptotes occur at every other multiple of 90. 90, yes. 180, no. 270, yes. 360, no. Same thing here. The asymptotes occur every other multiple of 90, but at a different starting point. 0, yes. 90, no. 180, yes. 270, no. 360, yes. Okay, so it just kind of shifts over by 90 degrees. Okay, and what you're looking at on the screen right there, that's exactly one period. You're looking at 2 periods there. 2 periods, 1 period. This period starts at 0. It ends at 180. So how wide is that from 0 to 180? What's the width? $180. Okay. That's different than sine and cosine. Okay. Sine and cosine, the width of one period is 360, or 2 pi. For tangent and cotangent, those two are kind of weird. The width is only 180. Okay, so that's what I just said to you. The period of tangent and cotangent is pi, not 2 pi. Tangent and cotangent are kind of the weird ones, okay? Sine has a period of 2 pi, cosine has a period of 2 pi, secant has a period of 2 pi, cosecant has a period of 2 pi. Everything is 2 pi except tangent and cotangent. They do their full cycle in pi, not 2 pi. So what that means basically is you get the same value every 3.14 units. Let me show you that as a picture first. That value right there is going to occur again right there. And it's going to occur again right there and again right there. How often is that value reoccurring? Plus pi, plus pi, plus pi. The value is repeating every 3.14 units. And it can go the other way too. Go either way. That's what that means. And it's exactly the same for cotangent. If you pick a value on the graph of cotangent, that same value is going to occur again 3.14 units later on the x-axis. This value would occur again right there, and there, and there. Every 3.14 units in both directions. But you don't just have to go 3.14, you can go another 3.14, and then another 3.14. So you can go multiples of 3.14, as many as you want. But you have to go a full multiple. You can't go 1.5. You either go 1 or you go 2. If you go halfway between, you're going to end up here. Well, that's not on my graph at all. Going to go a full multiple to get to the next line. Okay, any questions on that? All right. So, we've looked at transformations for sine and cosine. Every single transformation is exactly the same for tangent. In fact, if you know that by now, you really don't even need to write it. Okay, but if you don't remember or you need a reminder for the 10th or 20th time, there's the formula. So your phase shift, it's inside the parentheses with addition. Period change, That's in front of x with multiplication. Amplitude change, that's in front of tangent, or in front of the function, multiplication. And lastly, your vertical shift is at the end. Remember, A and B do the opposite of what you would expect. If you put a plus for A, it shifts left. If you put a minus A, it shifts right. Big number for B compresses the graph. Small number for B makes it bigger. C and D do exactly what you would expect. Plus is up, minus is down. C, big number makes it bigger. Small number compresses it smaller. So somehow you've got to keep all that straight. You can replace the word tangent with any function. Sine, cosine, secant, all of the transformations are the same. So it's nice about them, they never change. Okay, does everybody have the formula? All right. So, if I ask you to find the period of a function, okay, we've done that with sine and cosine. And the formula was 2 pi over b. Not with tangent and cotangent. Tangent and cotangent, they have a different formula. Pi over b. Because their period is not 2 pi. It's pi. Okay, so to find the period of tangent and cotangent, use pi over b. Now, another thing that they will probably ask you when you graph tangent and cotangent is, where are the dotted lines? Where are the vertical asymptotes? I didn't ask that question with sine and cosine because there weren't any. But now there are. So I'm going to tell you, how do you figure out where the asymptotes are? In fact, when we study, in a minute, I'm going to show you the graph of secant and cosecant. Those graphs have asymptotes too. Sine and cosine are the only nice ones. So I'm going to show you how to find the asymptotes for any trig function that has asymptotes. Okay, the first step is to focus on one section. Don't look at 6 sections at the same time. Focus on one section. What section should you focus on? It doesn't matter. Any section you want, but pick one section. Look at that on the screen. Once you find that one section, you're going to find all the asymptotes in that section. Okay, so let's go back and look at the graph of tangent. And just make sure we understand where a section begins and where it ends. Or cotangent, it doesn't matter. All right, so in between those red lines is one section. But we just have to explain, like, is the dotted line part of the section to the right of it, or is it part of the left of it? It can't be in both. So let's say that that blue dotted line that I'm pointing to, which will be easier to see if I move that away. Let's say let's try again. That dotted blue line is part of that area. That means this blue line, we'll say, is part of the second section. This blue line is part of the third section. Okay? So we just have to be clear that in this case, there is only one vertical line per section. There's not two. Okay? First blue line is part of the first section. The second blue line is part of the second section. Don't say that there's 2 blue lines in the first section. There isn't. There's only one. Okay, one per section. Any question on that? The blue line can't be in both. It has to be in one or the other. So there's one asymptote per section. Okay, so find the asymptote first in one section. And for tangent and cotangent, there's only one to find. There's one asymptote per period. If you want to write that down, maybe that's something that's helpful. Tangent and cotangent, there is one asymptote per period. All right, so now how do you find where the asymptotes could shift to? Because remember, if you do a transformation, not only does the graph move, but everything about it moves. Asymptotes are going to move too. So take your original asymptotes, plural if there's more than one. For tangent and cotangent, there isn't. And set them equal to the argument. What's the argument? That's the argument. So find an asymptote, set it equal to what I just circled, and solve. And now remember, asymptotes, or any point in the graph, it reoccurs how often? Well, if the period was pi, whatever the period is, right? So the asymptote is going to reoccur every period. You're going to keep getting them forever. So if I ask you, write an equation that shows me where all the asymptotes are, you can't list all of them. There's infinitely many. This is how you write all of them. Take your asymptote you found in step 2, and then put plus the period times n. If it was pi, you would put plus pi n. If the period was 7 pi, you would put plus 7 pi n. Okay. And if you're like, well, how do you find x1? That's what we did in step 2. How do you find the period? Right there, to find the period. We use that formula. Okay, so we'll go through an example. And in a little bit, I have a chart for you that summarizes all the functions we're going to study today. Very, very nice. Tells you where the asymptotes are. In fact, I'll just jump to it real quick, but I'll come back to it later. This table gives you a formula for how you find the asymptotes for any trig function. Where the first one is, and then if you transform it, where the new one would be. You just have to follow that chart. Okay. Right now, we've only talked about those two. All right. Okay, does everybody have that? All right, now, good time to try an example. And in the example, I'm kind of leading you through what you need to do to answer the later question. So I'm asking you something about finding a complete graph. Well, to do that, you need the period. That's the first thing I ask you. What's the period? Okay. For tangent, can someone tell me what's the formula to find the period? And,
Or pi over b.
yeah, in this case, it is going to be pi over 2. But it's pi over b, not 2 pi. If I change that to a sign, then it would be 2 pi. Okay, so there's the period. Now it says find a complete graph. Does that mean on the calculator or by hand? Calculator, right? Complete window, that's the calculator. We want to show 3 periods. Okay. What did we just say? How big is one period? One period is pi over 2. I want to show 3 periods. So triple that. What do you get if you triple that number? 3 pi over 2. So one way to show a window that's 3 pi over 2 units wide is start at 0 and end at 3 pi over 2. That's probably the simplest way. There's other ways. You just have to have a width on the screen That's 3 pi over 2. That's why I did 0 to 3 pi over 2. And I have to type in tangent 2x, because that's my graph. And now I should see exactly 3 sections of tangent. Hey, do I have 3 sections there?
You have 2 and then half of each, but they're the opposite half, so kind of you have 3.
Yeah, I have 3. It's just I'm looking at a half, a whole, and then the other half. That's okay. That's still 3 sections of tangent. If you wanted to make it look a little nicer, you could shift your screen to the left a little bit and then get 3 sections that are all connected. But that's perfectly fine to show 3 periods. Does anybody want me to adjust the window to show it so it's 3 connected sections?
How would you find the number to find where it is?
Well, the way I would do it is, I know that it looks to me like it's about 90 degrees off. How do I know that? Because each section is 180. So that's half a section, right? So that's 90. So I want to get rid of that 90. So if I bump everything 90 degrees one way or the other, then it would work. How would you do that? Yeah, you would just add, you could take the x window, and let's shift everything to the right, pi over 2. So just take that number, add pi over 2, and the calculator will figure it out. And then add, yes, yep, it would be. Add pi over 2 to that number. Now I didn't change the width. All I did was take each number and bump them together to the right a little bit. And now you're going to see 3 connect. Did I bump it too much? Yeah, I think I went too far. So now you're seeing 2 sections again, but you're still seeing the half and the half. So I would probably have to adjust it by 45. You don't have to worry about that. Okay. But that's another answer to the question. That answer is fine too. So yeah, I was wrong. You'd have to bump it 45 degrees, pi over 4, half of it.
And if you choose the y minus x.
With tangent and cotangent, since they go up and down forever, -4 to 4 is always good. Or -6 to 6, somewhere around there. Yep. All right, so now looking at those 2 pictures, one of them is the graph of 2 tangent x, one of them is the graph of 5 tangent x. I just want to know which one is which. First, what does putting a number in front do? Stretch, right? Vertical stretch. So one of these is stretched vertically more than the other. So is the one on the left the 5 tangent x or the one on the right? Well, think about what would happen if you had something that had a curve in it and you started to stretch it.
So the one on the left is 5.
Yeah, it would start to almost look like it's straightening out, right? If you stretch it out. So this is 5 tangent x, 2 tangent x. Okay, if I gave you one on the test like that, I try to make it pretty clear which one is which. I wouldn't give you like 2 tangent x and 3 tangent x. Those would look kind of similar. But I'd make it look different enough. Okay, questions on that? All right. Okay, so that's it for tangent and cotangent. Okay, we're not spending any more time on them. Okay, so I told you, not as much as sine and cosine. So the last 2 are secant and cosecant. Like tangent and cotangent, they look very similar. And what I've drawn here is multiple sections let me put a box, or let me put two red lines around one section. Black lines work too. Inside those black lines, that is one section. So it's like a U shape and an N shape. So right now on the screen, you're looking at 1, 2, and then like 3 kind of sections, but chopped up a little funny. So how many green lines are there per section?
6.
Per section?
Per section.
Oh, yeah.
No, 2.
2. Right? We could say this line, not going to draw it because that'll look confusing. The first line and the second line are part of the same section. When you get to the third line, that third line, that's the boundary on the left side of the U shape. Well, we already had a boundary on the left side of the U shape. So when you get to the left side of the U shape, you are starting a new section. So first line, if I call that the first line, the second line, those are in the same section. Third line, that's the start of the next section. Fourth line, same section. Fifth line would be the start of the next section. So there are 2 asymptotes per period. You don't really have to memorize, well, where are they? Are they at pi over 2? Are they at 3 pi over 2? I'm going to give you a chart in a second that tells you exactly where they are. So you don't have to worry about copying these asymptotes. Now, if you look quickly, you might just say, well, aren't they the same? Not quite. Just as an example, look at the U shape here. The U crosses right through the y-axis. The y-axis splits the U in half. The y-axis does not split the U in half there. So the difference between secant and cosecant is kind of like if you take secant and bump it to the right a little bit, or to the left, then it would look like cosecant. And when I say bump it, I mean 90 degrees. If you shifted everything here 90 degrees one way, it would look like the other graph. Okay, so some similarities with tangent and cotangent. You have asymptotes. You have a repeating pattern of U shapes and N shapes, 1 U shape and 1 N shape per section. And the asymptotes occur with the same frequency as they did before, every other multiple of 90. It's just you have to figure out where is the starting one. These are the first 2 asymptotes for secant. 0 and pi are the first 2 asymptotes for cosecant. The reason that's important is because if you do a shift and you want to know where are my asymptotes now, you have to know where they were before. You can't figure out where they're going to be now if you don't know where they were before. And that's what the chart on the next table is really going to be helpful for. Okay, so what was the period for sine and cosine? The ones we've been studying all week. If you don't mess with it, you don't change it, what's the regular period for sine and cosine? 2 pi. Right? 2 pi over b. So now, secant and cosecant, that's the sine and the cosine flipped. So these 2 functions are directly related to sine and cosine, and they have the same formula for the period. 2 pi over b. So the only function that doesn't use 2 pi over b is tangent and cotangent. Everything else does. All right, so now I'm going to put up a chart and try to make it as simple as I can for how you find the asymptotes in any function for any transformation. So the first thing that you have to know is, where are the asymptotes starting originally? Where are they? For tangent, first one is at pi over 2. For cotangent, the first asymptote is at 0. Why did I only list one in each? Because there is only one. There's one asymptote per period. For secant and cosecant, I asked you how many green lines per period, and you said 2. That's why there's 2. Your first two asymptotes for secant, your first two asymptotes for cosecant. And now to find the new asymptotes, you use these formulas. And if you're looking at it, you're like, well, he explained how to find the period. That's either 2 pi over b or pi over b. So you've got the formula for that. How do you find these x1s and x2s? I just gave you notes on that, and I'll come right back to it. But those are the notes I gave you right here. Set the original asymptote equal to the argument and solve. Okay? So if you're wondering, how do you find the x1s and x2s? Put a note and say, go back and read step 2. So it's step 2 from 4 slides earlier. I'm not going to write that all again. Okay, for tangent and cotangent, you would only have to do step 2 once. For secant and cosecant, you're going to have to do it twice. Set the first one equal to your argument, set the second one equal to your argument. So you're going to have to do step 2 twice. But that's as simple as I can try to make it to find the asymptotes. Okay, these graphs are not as simple as sine and cosine. They are more complicated, so naturally it can't be as simple as sine and cosine, but that's the best we got. Does everybody have the table? You really, for secant and cosecant, you could just put like a bracket like that and just point. You only have to write it once because it's the same thing. Same thing here. Just put a bracket like that and just put it once. Okay. So this question says, find the domain, range, period, and vertical asymptotes of secant. I'm actually going to start with the last thing, the vertical asymptotes. Now, are we doing anything to the secant function? Like, are we stretching it? Are we shifting it? Are we changing the period in example 3?
No.
No, it's just a basic secant function, so I don't have to do anything. So all I have to do to get the vertical asymptotes for secant is look them up on my chart. Pi over 2, 3 pi over 2. Remember, vertical asymptote is always x equals a number, y equals this horizontal. And the reason I started with that is because now the domain is easy. The domain is every number that's not an asymptote. So I'm just going to write that. So domain is all values except the vertical asymptotes. The range, well, let's look at the graph. So to graph secant, I have to flip which function?
Cosine over
1 over sine would be cosecant. So 1 over cosine. If we look at that graph, does it look like the graph goes down forever and up forever?
Oh, yeah.
Yeah, I don't have a good picture of it, but yes, it will go down forever. If I zoom out, you'll see it better. It will go up forever. Does it hit every value in between going up and down forever? No, there's a gap. There's a gap in the middle that it never gets to. Does anyone have a guess what the minimum is?
1.
Yeah. So this is going to hit every value from 1 and up. Okay, so that's part of it. So you'll hit 1 to infinity, and you're going to hit negative infinity up to how high are you going to go? Negative 1. Yep. And if you weren't sure, you could do second calc minimum or maximum, and you could see that. Okay. Any questions on that? That's my range. What else do they want? Period. Okay. What's the formula to find the period for a secant function? Pi over b, that would be for tangent and cotangent. 2 pi, yeah. So 2 pi, what's b in this case? 1, and we didn't change anything. So that's everything they want. Let's try. Does anyone need to do it for cosecant? It's going to be pretty much the same. The range is going to be the same answer. Domain is going to be the same answer. Period is going to be the same answer. The only thing that's going to change is the vertical asymptotes. It's not pi over 2 and 3 pi over 2. It would be 0 and pi. That'd be the only difference. This one. Find the period and the asymptotes of cosecant 3x. All right, so now we're changing a little bit. Okay. What are the 2 original asymptotes for cosecant? 0 and pi. Now, the directions in step 2 from 5 or 6 slides ago said to take the original and set it equal to the argument, which is 3x. That's going to be one of my new asymptotes. That's going to be another of my new asymptotes. So, divide by 3. We get x equals 0. That one didn't move. Divide by 3. Divide by 3. We get x equals pi over 3. So what we just found, what are we doing, cosecant? We just found this and that. We found 2 specific asymptotes, but they reoccur every period. They're going to keep repeating. So what is, what's the period of this? What would be the formula to find the period?
pi over 2.
2 pi over 3. That's the period. So if the question said describe all the asymptotes, you're going to get that asymptote, and it's going to keep repeating. How often? Every period times n. Every multiple of the period, you get another one. So 2 pi over 3 times n. So if you add 2 pi over 3 to 0, you're going to get another asymptote. If you double 2 pi over 3 and add that, you get another one. Every multiple. And that asymptote at pi over 3 doesn't just occur one time, it's going to keep repeating. It's going to repeat every period. So plus 2 pi over 3 n. That describes every single asymptote in this function forever. Okay. And the period. All right, show a complete graph of 2 periods. Well, if one period is 2 pi over 3, how much is 2 periods? Four pi over 6, that's the same as 2 pi over 3.
6.
Sorry. Yeah.
4 pi.
4 pi over 3. So if you wanted to show 2 periods on the calculator, on your window, set it from, I'll just show you. Set it from 0 to 4 pi over 3. Now if we type that in, we should get exactly 2 U shapes and 2 N shapes. One U shape and N shape together are a period. So 1 divided by sine 3x. That's the only way to type that in. 1 divided by sine. That's your first period. And then that is your second period. So that's exactly 2 periods. Any question on how we got a picture of 2 periods? Okay, it takes a little practice to get used to working with these because they're a little harder than sine and cosine. All right, so the last thing we're going to do, probably the easiest thing, is using the calculator to solve equations. Assuming you can type it into the calculator into y1 and y2 correctly, all you have to do is find an intersection point. That's it. But if 2 trig graphs cross once, how many times do they really cross if you were to keep zooming out?
2.
Let's say you had this picture and this picture, and you keep extending those waves. Infinite. So if they cross once, they cross infinitely many times. How often do you keep getting an answer where they cross? Every what?
A period.
Every period, whatever the period is. Okay? The answers reoccur every period. So, if you can find one solution, then you can find infinitely many. So suppose you use your calculator, you do second calc intersect, you find one solution. The way you would write all solutions is take the one you found and put plus the period times n. Right, so we'll just make up a simple number. Let's say you did second calc intersect and you got an answer of 2 and the period was 3. Well, that means you're going to get another answer at 5. You would get another answer at 8, at 11. You're going to get another answer every period, every 3 units. I just picked a simple number. And that works the other way too. If you go back a period, go back 3 units, that'll be another answer. Okay, so find one solution, put plus the period times n. And that's all. Okay. So the directions here say find all solutions. When it says all, what does that mean you have to put on the end of it?
Plus period.
times
N.
n. So you got to do plus period times n. But that's no good unless you know how to type that in and find the starting solution yourself. So how do I type in cosecant?
Would that be cosine?
No, not cosine.
Sine.
Sine. What do I do with it?
Divided by 1 over sine.
1 over sine. Okay, so what I'm doing is I'm graphing cosecant in y1. What am I going to put in y2? Negative 1.6. And it doesn't really matter what you set your window to. As long as you set your window so you can see one intersection, that's all you need. It doesn't matter which intersection you pick. Pick any one you want. I usually pick the first positive one. All right. So now if we look at that, how many solutions do I have per period?
2.
2, right? If I want to focus on one period, look inside this box. Forget everything else. Those are all the answers in one period. Any question on that? Now find each of them. Let's start with this one. So secant, calc, intersect. And I'll get the first one. So I get 3 point, and I'm in radians, 3.82. Okay, now find the other one. Second calc, intersect. Because there's multiple ones, I got to put the guess a little closer to the other one. 5.61. And now, how often are those answers going to keep repeating? Every
period.
every period. So you're going to get this answer again right here. You're going to get this answer again right here, and forever. So the question is, what's the period? We graphed cosecant. So what's the regular period for cosecant? No change to it at all. 2 pi. So if you said to me, what's the next answer after 3.82? I would say it's 3.82 plus 1 multiple of 2 pi. What's the next answer after that? Add another multiple of 2 pi. And another, and another, and another to keep getting all the answers. All right, so we'll try one more. So the last one will be find all solutions to tangent x equals 2.5. Can someone walk me through that? What's the first thing I have to do? Put it what? Yeah, put it into y1 and y2. Exactly. And now this time you have a button for tangent. You don't have to flip anything. So tangent in y1, 2.5 in y2. Okay, I'm going to ask the same question I did on the last one. I see a bunch of answers on the screen. There's a bunch of intersections. How many per period? 1. How do you know there's 1? Well, look at the screen. Focus on one section. A section is one curved segment. That is one section. So let's find that answer. If you were like, well, could I start with this answer instead? Sure. You can start with any answer you want. You just have to find one. I do the first positive one. That's what I do. So second calc, intersect. Blue, red. So we get an answer at 1.19. And now, how often is that answer going to keep repeating? Every period. So what's the next, or what's the period of tangent? Well, it's pi over b. And what's b in this case? Okay, you're just focusing on this. No, don't focus. The 2.5 is on the other side. You're just looking for the period of your trig function. Well, what does that say? What's in the red box? Tan. Just tan. What's the period of tan? Pi. There's no period change at all. If there was a period change, you'd have a number in front, like a 2. There's no number. So, if you wanted to know where the next answer is going to occur, in the positive direction, it's 1.19 plus 3.14. That's the next answer, 4.33. Let me check and see if that works. So this intersection should be 4.33. And there it is, 4.33. The next answer after that, 7.47, 10.61. Just keep adding 3.14, and you get more and more answers. Okay, so only time you have to put this plus pi n on the end is if I write what I just underlined. All solutions. If I said to you on the test, just give me one solution, 1.19 does it. That's all you'd have to put. Okay, so that's the homework tonight on 352. I will be after school today if anybody needs to come for extra help. We'll go over that first thing before the test tomorrow, and then we'll do the test, and then that'll be it.